Purpose of this video is to work some problems. I think we are going to work this one, which is demo for video 4, lesson 3. I really struggled with whether or not to include this instructional video. But what I found is no matter how well students may understand a content and how well it's been taught to them, sometimes there's a disconnect or possibly a gap between being able to understand the concept and apply it to questions like they see on my stat lab, for your assignments and of course your exams. So I just want to make sure there's no gap, if you will. So this is the first time I've worked these problems, and looks like there are 6 of them, so it shouldn't take long. So again, work along with me and get some easy points, okay? So find the indicated z-score. The graph depicts a standard normal distribution. So we need a z-score that has 0.9099 area to the left. So that should be pretty straightforward. So go to the normal distribution. Make sure the mean is 0, standard deviation is 1, and I need less than some value that has 0.9099 to the left. So rounding to 2 decimal places, we need 1.34. And it should be pretty straightforward. Next question, assume that a randomly selected subject is given a bone density test. These test scores are normally distributed with mean 0, standard deviation 1. Draw a graph and find the bone density test scores that can be used as a cutoff to separate the lowest 21% and the upper 21%, indicating levels that are too low or too high, respectively. Well, we know that looking at the region, that if we have the highest 21% and the lowest 21%, the only graph that could represent that is A. These are corresponding in adjacent areas. This is corresponding and adjacent below. Again, this is corresponding and adjacent above. And this is the area between 2 scores. So the only thing that could align with the question is part A, or is option A. The bone density scores. All right, so what we need is there's a couple of ways we can do this. All right, so really the between doesn't work because the between would give us model a phenomena like what we see in D. So what we have to do is we work the standard, but we have to work it one at a time. So I need the lowest 21%. So I need less than, so 0.21. So let's see the z-score that corresponds to that. So that would be negative 0.8. What are we, 2 decimal? Okay, so negative 0.81. And of course, the right side is going to be positive 0.81. Now, if you don't see that because of the property of being symmetric, we could just do greater than, put 0.21 at the top of the distribution, and we'll see we get the positive of that. All right, next question, find the shaded region. So we have IQ scores, mean of 100, standard deviation 15. And we need the area between, so between applies. So let's put in the correct mean. Put in the correct standard deviation. We need from 104 to 128. The area is rounded to 4 places, 0.3639. All right, these are going pretty fast, right? So find the indicated IQ score. The graph to the right depicts IQ scores. I mean, 100, standard deviation 15. We need the IQ score that has 75% of the distribution to the right. So again, very simple problem. So check the mean, check the standard deviation. We need the area to the right to be 0.75. So we're looking for the IQ score, which in this case round to 1 decimal place as needed. So that would be 89.9. All right. Assume that adults have IQ scores that are normally distributed with a mean of 100.3 and standard deviation 22.3. Find the probability that a randomly selected adult has IQ greater than 125.1. Again, easy problem. Just change the mean, change the standard deviation, and we need greater than an IQ score of 125.1. So rounding to 4 places, our answer will be 0.1330. Okay, engineers want to design seats in a commercial aircraft so they are wide enough for 99% of all adults. Accommodating 100% of adults would require very wide seats that would be much too expensive, obviously. Assume adults have hip widths that are normally distributed with a mean of 14.3 and a standard deviation of 1.1. Find P99. Now remember, P99 is the percentile ranking, right? And the 99 represents, by definition, percentile is always area below, percent below. So we need the hip width that has 99% of the distribution below it. So start with putting in the correct mean. So it looks like it's 14.3. Next is 1.1, and we need the value that has 0.99 of the distribution, or 99% of the distribution below it. So it looks like rounded to 1 decimal place, we're at 16.9. And, oh, cool. That's it. All right. Hope this helped. Take care.